Hi, in this video we're going to start our talk about polar coordinates. So far in our talk of calculus, be it Calc 1 or Calc 2, we've been dealing with Cartesian coordinates, or rectangular coordinates. Those are x's and y's, where we can think of our point xy as somewhere on a grid of some sort. But this isn't the only type of coordinate system we can use in the plane to represent things. And sometimes changing our coordinate system makes things easier to work with, whether that be graphing it, integrating, finding an area, or taking the derivative and finding the slope of the tangent line at a certain point. So what is polar? So polar coordinates, we can think of them as an ordered pair, just like how we would with x and y in rectangular coordinates. So let's go ahead and just pick a point xy. And what we're going to do, instead of thinking it as we move over to the right x and we move up y, we can instead draw a line from the origin to that point xy. Now that has a certain length, and let's call that length r. And we also have an angle of inclination between the x-axis and that line that we drew from the origin to the point. Let's call that theta. So our point, or our coordinates here, are r and theta, where r is the distance, the straight line distance, so straight line distance from the origin to our point xy, and theta is the angle of inclination. So we can get every point in our Cartesian coordinates and represent them as some other point in polar coordinates. Now, how can we do this conversion? Well, we're going to look at our graph again, and we're going to pick any point xy, and instead of just imagining that there's a line there, we're actually going to draw a line and drop down perpendicular to the x-axis. Now, we still have our angle theta, and we have our r. So we want to get r and theta. Well, we can first notice that our height here is y, and our base is x. And we can use some basic trig ratios and some Pythagorean theorem to figure out what r and theta are. So we know that the Pythagorean theorem here tells us, so Pythag theorem, that tells us that x squared plus y squared equals r squared. And taking the square root of both sides, we get r is the square root of x squared plus y squared. And then we know that the tangent of theta, actually let's go ahead and highlight this. We know that the tangent of theta is equal to the opposite over the hypotenuse. So theta is going to be the inverse tangent of y over x. So say we wanted to plot 2 pi over 4. Well, we would have our graph here. We would have an angle of pi over 4. And we would go out a length of 2. So that's one way of looking at polar coordinates. Another way of looking at them is our r doesn't necessarily have to be positive. We can have negative 2 pi over 4. We'll make that positive pi over 4 still. And when we do this, we'll have our angle of pi over 4, but it's going to be along this line, but in the negative direction. And this is going to be our point, negative 2 pi over 4. So now let's do an example of converting Cartesian to polar. So if we want to convert negative 1, 1 to polar, let's start by graphing it. So negative 1 and 1, we have a point, negative 1, 1, here in the second quadrant. So let's first find r. So r is going to be the square root of x squared plus y squared, so negative 1 squared plus 1 squared, which is equal to the square root of 2. So that's our r. And let's go ahead and highlight that. Now we need to find theta. Okay, we know it's in the second quadrant, so we don't really have to worry about our positives or negatives all that much. So let's just find our reference angle. So you know that the tangent of theta is going to be 1 over 1, or we could say 1 over negative 1, or negative 1 together. So that tells us that theta is equal to the inverse tangent of negative 1. So theta is either equal to negative pi over 4 or pi over 4 as a reference angle in the second quadrant, which would be 3 pi over 4. And now we just have to look at which case it is. So this is in quadrant 4, and this one is in quadrant 2. And this is the one that we want, so our theta is going to be 3 pi over 4. So in polar coordinates, so negative 1, 1, goes to square root of 2, 3 pi over 4. And this is our conversion here. Now let's convert from polar to Cartesian. So let's just go ahead and make a point r theta, where this is r, this angle is theta, and we want to convert it to an x and a y. So we know that the tangent of theta is equal to y over x, but that's not really going to help us here. What is going to help us instead is that sine of theta is equal to y over r. And this is going to tell us that y, multiplying both sides by r, is r sine theta. And cosine of theta is equal to x over r. And that tells us that x is equal to r cosine theta. And that's it. That's our simple conversion from polar to Cartesian. So now let's go ahead and look at an example. So suppose we wanted to convert negative 2 pi over 3 to Cartesian. Well, we know we go up pi over 3, but instead of going up along the line, we're going down because it's negative 2. So this point is negative 2 pi over 3 in polar. So now all we have to do is find what this reference angle is. Or I suppose not. We could just use our change of coordinates and then double check to make sure that we're doing it right. It's always important to double check your answers. So we're saying x is equal to negative 2 cosine of pi over 3, and y is equal to negative 2 sine of pi over 3. Now, to double check, and if you're still unsure as to what the cosine or sine of pi over 3 are, like I always get confused, we'll just make a 30, 60, 90 triangle. Okay, and we know that this is a 1, 2 square root of 3 triangle. 2 is the largest, so it's the hypotenuse. The second largest is going to be opposite the pi over 3, and the smallest is opposite the pi over 6. So cosine of pi over 3 is opposite over hypotenuse. So this is the square root of 3 over 2 times negative 2. Negative 2 times square root of 3 over 2. And this is negative 2 times the sine of pi over 3, which is 1/2. So that tells us that xy is equal to negative square root of 3, negative 1. And negative square root of 3, negative 1 lies in the quadrant 3 space. So this is in quadrant 3. And we check out. This concludes our introduction to polar coordinates and how to convert them to and from Cartesian coordinates, how to plot polar coordinates, and come join me for the next video when we'll talk about some common polar graphs.